So hey guys, in this video we are going to take up what a Newton Raphson method. Okay, so the function we are going to take it as f of x equal to 3x minus cos x minus 1. So this is the function we are taking. Now how to solve this Newton using this Newton Raphson method, how to find the root of this function, that is the thing. Now the first step you have to do is that find where the root lies, between which two numbers the root lies. How to find? We have to find where the function will be negative and where the function will be positive. For that purpose, you have to just substitute some value for x. It can be anything. For example, if I put minus 1, what will happen? In place of x, I am putting minus 1. So if you put minus 1, it will become minus 3 minus cos of minus 1. One more thing, remember that put the radian R mode in what the calculator. So you'll be using calculator, in that you have to put what R radian mode. Okay. So cos of minus 1, this thing will do. You will be getting it as minus 4.54. Now we have to focus on what? The negative. That we have got one negative number. Okay. So if I go for f of 0, if I suppose put x equal to 0 in the function, you will be getting it as minus 2. And if we put f equal to f of 1, you're getting what? 1.45. I hope you understood what I am doing. That in place of x, wherever x is there in the function, I am substituting first minus 1. Just you can substitute any value. The thing is that you have to find out where the function will be negative and positive. Now minus 1, the function was negative, and 0 also function is a negative. But what happened, 1, when I substituted 1 in place of x, what happened? I got 1.45, which is positive. So that means the root lies between these two. Why it lies between these two? This is negative and this is positive. So that's why I said we have to find where the root lies. So it depends on negative and positive. Wherever you are getting negative and positive, that will be considered as the root lies between that. Can say x equal to 0 and 1. So 0 comma 1. That we understood. Now why we are doing this? We have to assume some value, right? So we have to assume let x naught. This is the initial approximation we have to assume. For that purpose, we are finding where the root lies. Now the thing is that for taking x naught, there are different ways. Okay, so I'll tell you each and everything. Now we have to focus on this as well as this. The first way is that which is nearer to 0. Now, when I substituted 0 as x, I got minus 2, right? Another thing is 1.45, which is nearer to x. We can say that 1.45 is nearer to x. So I can consider x naught as 1. I will consider x naught as 1. So by seeing this value which is nearer, I can consider that particular x value as x naught. This is the initial approximation. This is the first method. Okay, second method is that take the midpoint of these two. That means x naught can be this 0 or 1. 0 or 1 lies between 0 or 1, the root. So midpoint of that 0 and 1 midpoint is what? 0.5. So you can take the midpoint as what? 0.5. Okay, that is also thing. So second method is that. Third method is that either of them you can consider. See, you considered one x naught as 1. Here you are considering x naught as 0.5. You can consider x naught as 0 also. Okay, you can consider x naught is 0 also. Now we will be asking whether we'll be getting the same answer. Yes, we'll be getting the same answer. You can try it once by taking all the three values. Iteration, last answer will be exactly same. Maybe iteration may decrease or increase. That depends on whatever value you're taking. So in this, we are going to take the x naught value as 1, which is nearer to 0. So 1.45 is nearer to 0, so I am taking x naught value as 1. Okay, you can take other values and try also, you will be getting same answer. Now after getting the x naught value, after considering let x naught equal to 1, this is the initial approximation. We are going for the main step, which is to find the formula. I'll write x n plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, this is the formula for Newton-Raphson method. In this, we have to go for first iteration, second, third, fourth, like that, so on. Okay, so in the consecutive iteration, wherever you are getting the same value, we have to stop the process that we already know. Now f dash of xn is also there. So this is f of x. So what will be f dash of x? That also I'll write it over here. So f dash of x will be just a differentiation of this. 3x differentiation is 3. Cos x differentiation is minus sin x. So minus is already there, so it will become plus sin x. Minus 1 is a constant, so leave it 0. So this will be f dash of x that we have written. Now we'll go for the first iteration where the n value you have to substitute as 0. So when n value becomes 0, what will happen? Substitute here. It will become x 0 plus 1, 1, x1. This will be x naught minus f of x naught divided by f dash of x naught. That means what is x naught value? The initial approximation we have considered 1 minus we have to find f of 1 and f dash of 1, both the things. That means in the function you have to substitute 1 here also, here also. So when you substitute 1, what will happen? You will be getting the value as all you can substitute in the calculator. You will be getting 1.45. You can take up to 2 decimal places or 3 decimal places. 3 will be better. If 2 is also is fine. Maybe most of the questions will mention up to 3 decimal places, 4 decimal places like that. Okay. This is 3.841. After substituting, you'll be getting the x1 value as first iteration. We are getting x1 value as after substituting 0.6224. Okay. This is we have done with the first iteration. Let us go for second iteration. We have to substitute n is equal to 1. That means the equation becomes x2 x1 minus f of x1 divided by f dash of x1. Okay. Now what is x1 value? The previous whatever you have got the value, that value. So 0.6224 minus f of 0.6224 divided by f dash of 0.6224. So what is the value you are getting? You are getting the value as I'll write over here, x2 is equal to 0.6224. When you put in the function, what will be getting? 0.0547 divided by 3.5829. Okay. The final calculation 0.6071 we are getting. Okay. Now we'll go for the third iteration. Why we are going for the third iteration? Because since the first iteration we got the value of 0.6222. Consecutive iteration you should get the same value, approximately same value. Okay, it's a minute error should be there. So here it is 6071, here it is 6224. So there is a large difference. So we are going. That's why we are going for the third iteration as well. It will be x3 equal to x2 minus f of x2 divided by f dash of x2. It is equal to, now this x2 value is this one, so substitute here 0.6071 minus f of 0.6071 divided by f dash of 0.6071. When you substitute, you will be getting the value as I'll write over here, x3 is equal to, in the function, 0.0000505888 divided by 3.5704. 3.5704. So the final answer of x3 is 0.6071. So that means what? The previous previous iteration and the present iteration, we are getting the same value of x, right? So therefore we can stop the process because the error is 0. Or we can say if you consider more decimal places, the error will be very minute. So that's why we are stopping the process. So we can say that the root of the equation is 0.6071. So this is the root of the equation. So this is the final answer. So I'll just quickly briefly tell you so what I have done. Newton-Raphson method, they will give you one function f of x, find out f dash of x and keep. Now the thing is that you have to find where the root lies. Root basically lies between negative and positive value. So you have to find the function where it is negative, where it is positive. Okay, so you can try out many values. You can try minus 1, 0, 1, 2, 3, whatever. Wherever you're getting, here I got minus negative value and positive value. So that means root lies between this and this, between x equal to 0 and 1. That's why I've written x equal to 0 and 1. So how to take x naught, that is quite important. So x naught can be taken whichever is nearer to 0. So wherever you have got the value nearer to 0. Okay, minus 2 or 1.45. So 1.45 is nearer to 0. So that's why I have taken x naught value as 1. This is the one case. Another case is that you can consider, you can take the midpoint of these two values. Wherever the x naught value can be considered as midpoint of 0 and 1, which is 0.5. You can try out with 0 also. 1 I have taken, 0.5 I have taken. You can try out with 0 also. You will be getting same answer. There is no difference. Okay. So you can try out with many ways.